Independent of viewing distance, there's nothing that looks better than a properly done high dynamic range representation. If you truly have a high dynamic range monitor, the impact can be seen from across the room. It's just, wow, that looks really, really great. We've done some side-by-side tests where we've done 4K or 2160p against 1080p, and the 4K was done in standard dynamic range or existing HD dynamic range in color space, and we've compared that against an HD or 1080p set doing HDR, and people all say that the HDR with HD 1080p looks, wow, that is higher resolution, doesn't. So it really comes down to the combination of three factors. It's high dynamic range with the wider color gamut, and then 10-bit sampling bit depth. The triumph of those all together is the really wow impact, I think. And we call that at Ericsson, we call that HDR plus, because it's those three factors all acting as a single technology. It really will wow the user. And at the end of the day, you have to really show the difference to the consumer if you're going to have some type of value added to that, because again, it comes down to a business matter. If you sit more than 1.5, 2 picture heights away from a 4K. As a matter of fact, if you did 3 picture heights, which is the average living room away from it, it looks like HD. You just don't see it.
Sure.
And it's a shame to waste that technology. But HDR plus, you can see that from across the room. It looks great.
I mentioned an exhibit you should look at. Now I'd like to mention something you should read, and you can't read it yet. It's going to come out in the May-June issue of the SMPTE Journal, and it's a paper by Sean McCarthy of ARIS about interactivity between these different improvements in pictures. And one of the areas where there's an interactivity, we're all talking about how great high dynamic range is, but high dynamic range makes motion artifacts more visible.
Right.
So if you just go to high dynamic range and you're at 24 frames per second, then you're making the motion look worse.
Flicker becomes a problem.
Flicker becomes a problem, and so you do need to go to a higher frame rate if you want to maintain even the same level of motion artifacts that you had at 24 frames per second with standard dynamic range.
And just to add a little bit further to what Mark just said, in addition to high dynamic range, which clearly you can see that that pop when you're seeing it, so it actually emphasizes, because your eye is much more sensitive to contrast, which is really what high dynamic range is, wider contrast. You interpret it as spatial resolution, but on top of all that, because if you are sitting at the right viewing distance to a 4K monitor, or for that matter 8K, which would be even closer, 3/4 of a picture height away from it, that means the display is closer to you, which means if it's 16:9, the arc angle that any motion would cross is much wider. Instead of looking at it with your eye, you actually might have to turn your head a little bit for that. Mm-hmm. And because of that, it does overemphasize motion artifacts, even in addition to just being high dynamic range, because you physically are crossing a higher arc. So that would be, if you want to get static resolution with dynamic resolution, you know, there's a lot of gain with any sort of motion, any sort of decent motion at all, where you would want to have a higher frame rate. If the goal, again, is to have natural, real-looking motion.
Right.
As you know, 24 frames per second, one of the reasons why producers want to keep with that, or directors want to keep, because they want the surrealistic look of film. So it does come down to artistic intent as well.
What we do is we take 3 identical size screens that are 65 inches. One of the screens is true 4K. The second one is a 4K monitor, but we're only feeding it with 2K 1920 by 1080 and allowing the set to do an internal up conversion. And then the third monitor is, again, 65 inches, but only 2K. And we put the identical content up on it. They're all color balanced, and we say which is which.
Okay.
And as we said from Matt, if you're at 3 times picture height, which is the ideal viewing distance for HD, it is very, very difficult to tell the difference, if not impossible.
Right.
When you get to 4 feet away, which is 1.5 times picture height for a 65-inch monitor, then you have a good chance of guessing which is the HD. But people still confuse which is 4K and which is the up-converted version.
Sure.
To your point about eye fatigue, we have a 4th monitor that we allow to do an internal up conversion through a transfer function that's built into the monitor to high dynamic range. So it's going from a 200 nit monitor next to it to a 400 nit monitor. And after you watch that for about a half an hour, because your pupils are going open and closed, you do experiencing some eye fatigue.
Right.
So I think it's important to realize that if you push this technology too far, it has consequences. And we've heard from color graders in Hollywood that they need a break after a half an hour of
Wow.
color grading a film in high dynamic range. And even some of the monitors that we've just acquired 2 professional 1,000-nit monitors. In the manual, it has some warnings saying that if you experience eye strain, stop using it.
Stop watching TV.
So,
This is one thing, every time we change to a new technology, we learn things. And we went from SD to HD, we found out that pans and zooms had to be done differently, otherwise you could get awkwardness, or like I said, some viewer being uncomfortable. And the same thing with high dynamic range. And one thing we haven't said here, because we all live this every day, all of us up here, is the fact that high dynamic range is not about being brighter. It's not about cranking your, if for those that have seen This is Spinal Tap, it's not about cranking your television's brightness and contrast both up to 11 because you can do that. Because that actually makes the picture look worse and heavily fatigued. It's about having the difference between the brightest whites in the highlights of the display, which are very, very small regions, and make it look more real, because we're so used to looking at something that's heavily muted. I mean, sunlight reflecting off of a car is probably several 100,000 nits worth of brightness, and on a TV it's a few hundred. So you can see that difference, and it's that level of control. If you do it well and you're just not making everything brighter, you would control that level of brightness. It's something that we were joking about earlier. You know, we had to deal with the COM Act and on the loudness. This is sort of like video loudness, right? It really is about making sure there's do some proper control this so that you don't oversaturate. And one thing we haven't really grappled with a lot, and we're just starting to look into this, was what happens when you have a main piece of content or essence, and then you have interstitials that are being done, particularly advertisements.
Right.
And just like you had with advertisements where they wanted to be noticed, so they would go bang really, really loud with the COM Act, you wanted to bring them down, audio normalization. This is the same thing. What if people really want to make them bright and have the high dynamic range be different than the main content? So I think we do have to do a lot of study into that and look at what happens when you transition from a main content to something else. You might be in a quiet part of an episodic or something where you're sitting on the couch, it's a dark room, and then bang, you get a really bright commercial that comes on. And think about what that would do to your eyes, because just like when you go from a bright room into a dark room, you don't see anything and your eyes adjust, and then you look at things in the dark shadows, and what happens when someone turns a light on? It's uncomfortable, and that's what could happen if we're not careful.